pros, bolts, and threaded features are common methods for assembling and aligning mechanical components, or transmitting motion.
Today, we'll look at how to combine standard hardware with 3D printed parts, as well as guidelines for including threaded features in printed parts themselves.
Let's take a look at some common methods for joining 3D printed parts, along with the pros and cons of each method. One option is to include threaded geometry on the printed parts themselves. While this technique can be very effective, there are some guidelines to follow for success. Keeping thread profiles larger and reducing the stress concentrations with fillets will make your assembly stronger and help your threads last. When possible, instead of using machine geometry for threads, use thread forms that are designed for plastics, like SPI dimensional specifications. The finer the thread, the more fragile the part will be, so avoid using thread profiles smaller than 1/4 20, especially if the parts will be assembled multiple times. Alternatively, you can use a tap to cut threads in printed parts. Cutting threads after printing will typically result in a cleaner thread profile, but adds to total build time and requires additional tools. Another option, if you need smaller thread sizes, or you expect to be assembling and disassembling the part frequently, is to combine the printed plastic materials with metal hardware. There are a few popular methods for using metal hardware with printed plastics, such as threaded inserts and nut pockets. The printed part is designed to capture the metal component and prevent it from rotating while fasteners are being installed or removed. This can be done mechanically by the geometry of the part or chemically by bonding metal hardware to the printed part with adhesives. Similar to threaded inserts, nut pockets use surrounding material to keep a piece of hardware in place while a screw or bolt is fastened. In this case, we're using a simple triangular pocket that prevents this hex nut from rotating during assembly.
Now, let's look at the consideration for 3D printing threads and how to apply them to your model.
Here, we're using existing designs and modifying our part in CAD. You need to make sure that your widths and depths have tolerances built in that can be achieved by your 3D printer. Because screw thread tolerances need to be in relatively narrow range to be effective, it's important to use a fabrication process that is precise and accurate. In this case, we are using the Form 3 desktop 3D printer. When preparing your models for printing, it's important to minimize support structures on any of these threaded surfaces. This will ensure that your geometry is accurate and that parts will come together easily without extra finishing work. In this case, we are using Formlab's durable resin as our material. The low surface friction of durable resin makes it a good fit for printing parts with threaded features built in. If you're using threaded inserts or nut pockets, tough, Grey Pro, and rigid resins are popular choices due to their strength and stiffness.
If you're interested in learning more about Formlab's 3D printers and the applications we have available for engineering resins, request a free sample of durable resin next to this video.